Hello there. In the last video session we have seen how to identify the centroid for a curved shape of the wire. Suppose that is we consider as a one-dimensional object. In this case also we do have taken the one-dimensional object, and that is in the straight line, and then let me find out the centroid. So how to do that part? We are using the same procedure over here to find out the centroid. So here the problem, find the centroid of a straight uniform wire length is given. So in this case the shape is going to be existed. The assumptions already we told here. This is going to be in a straight line. It is existed a straight. Next, uniform, that means the uniform cross section we do have. Similarly, it is in the homogeneous in this structure. Homogeneous means in this case what will happen? The rho is going to be constant. Uniform cross section is area is going to be constant for this part. And similarly, the total length we do have taken, the L is going to be your total length is going to be the L is. So now what is the next step we can do? So in this case we are going to be trying to do the number of segments. Before that we are trying to take the coordinate system. The difference points we need to take it to find out the centroid. So for this one I am going to be taking in these directions and in this direction. This is going to be your x, this is going to be your y. Distance I have taken. So then how to find out the centroid for this part? So in this case this is the one-dimensional object. It means that the length of is going to be distributed along the x-axis but not in the y-axis. At the same time, can you see here with reference to x-axis, this is going to be the one-dimensional, means there is no that level of the material towards the y-axis side. So then in this case first we have to find out the centroid with respect to the y-axis. So then how could you do? The first step is that we need to make the number of segments. Right? 1, 2, 3, 4, 5, 6 like this. The number of infinitesimal segments we need to take it. Then we know the procedure how to do that part. So in this case we need to take the mass. How could you find out the mass for this one? The total mass already we have taken. The total mass of this, the straight line y, that is equal to, that is going to be rho into volume we have taken. So the volume I am going to be writing in terms of rho A L I am going to be taking. This is going to be the total mass of that body. Similarly, we have the elemental strips we have del M1 is equal to, that is equal to what is that one? Rho A del L1 I am going to be taking. So the distance, this is going to be L1. This is going to be del L4. Like that, the elemental strip has its own length is available. So that going to be I have taken. Similarly, del M2 is equal to rho A del L2 I am going to be taking. These are going to be the elemental strips length we have taken. So then after that what we did it, we applied the theorem of Varignan. So then in this case what happened, y-axis is going to be our reference because the material is started to distributing towards the x direction but not in the y direction. So then how could you do this part? So in this case I am going to be taking. So the total mass already we have calculated. Now we are going to be taking the centroid. So I am assuming that this is going to be the one segments we do have taken. So the number of segments. In this case what will happen? The resultant of that means the momentum of the resultant of the force with respect to one axis is equal to the sum of the moments of individual components about the same reference axis we are going to be taking. That means the momentum of the individual forces along the reference same axis we have to take it. In this case what will happen? I am going to be taking the centroid by assuming that is going to be xc distance we do have, and this is going to be your the del L alpha I am going to be taking in that case. So we need to find out the centroid for this part. So from this one we are going to be taking the moments, that means the resultant moments, that's going to be moments into x is equal to del mi xi we have taken because we are taking with reference to the y-axis. So then how could you calculate this part? Already we told the rho A is going to be the constant throughout the length of this part. So then how could you calculate this one? What is the centroid distance I have taken here? That's going to be the xc. At the same time, the lengths are going to be existed. This is, suppose this I am going to be taking in terms of the L, suppose dl I am going to be taking, that's going to be 0 to L. So similarly that is equal to, we have the individual components. So that how could you take the individual components in this case? That's I am going to be taking So in this case, what will happen? We are taking the resultant component. So sorry for this part. Then I'm going to be taking here m is equal to be rho a l into xc. I'm going to be taking, because this is going to be the total mass of this wire, that is into xc is going to be the center distance, or x bar I am going to say. That is equal to, what is the mi? This I am going to be writing in terms of, this is going to be existed and 0 to L distance we do have, and then x into dx I am going to be taking. So because this is the dl, suppose dl is equal to dx. So on this basis I am going to be deriving these equations. So we know that Ra, and in this case also Ra, that I am going to be is going to be cancelled. So then L into xc, that is equal to, in this case, x squared by 2 into 0 to L, we got it. So then what I am going to be doing in this case, xc is equal to, that is the centroid, so that is equal to x2, I am going to be substituting L and 0. So L is going to be L squared by 2 we are getting, and this is going to be the 0. So then in this case, Lxc is equal to L squared by 2. Further simplification, xc is equal to L by 2 we are getting. So this way we can calculate the centroid of this line segment with respect to the y-axis, because this is going to be distributed in the x-axis, not along in the y direction. Suppose if the object is going to be in the vertical direction. So I hope you are able to understand this part. Suppose I have taken the same object in terms of this is the x-axis, this is the y-axis, and the material is going to be distributed the length in this direction. This is the y and this is the x. The same condition we are going to be applying here. So then same time we are taking the number of segments. Then we are going to be calculating this is the yc is going to be the centroid with respect to the x-axis. At the same time we do have the dy distance we do have in this case. Alright. So then in this case we do have the dy. And similarly we are taking the theorem of Berignan, and then we are going to be calculating what is the value we are getting here finally in this case. That's going to be yc is equal to L by 2. So assume that the total length is going to be L. So we can get the same. For this one, xc is equal to L by 2. So in this case we are not considering the distribution of the mass in the y direction. In this case we are considering only in the y direction, not in the x direction. So this way we can calculate it, your centroid.